What kind of truth was so scary that Einstein tried to hide it? 1917. Einstein applied his theory of general relativity to the whole world, but his equations showed something terrifying. The universe was breathing and dying. It was a nightmare. To calm everyone's fears, Einstein added a symbol, lambda, the cosmological constant. It was a patch to balance gravity and make a static universe possible, a way to hide the fact that the universe was collapsing. He breathed a sigh of relief, thinking that he had saved eternity. But the night sky had been telling a different story for over a century. The 19th century, a German doctor, Heinrich Olbers, asked a question. Why is the night sky dark? If the universe were endless and full of stars, every direction you look should end at a star's light. Similarly, if the universe were infinitely old and filled with infinite stars, then every line of your sight should end at a star. In that case, the sky would be bright, not dark. The darkness itself is the evidence. It shows a fact. The universe must either have an edge or a beginning. It's just that the light simply hasn't had time to fill the darkness yet. But physicists chose to ignore it until the 1920s. First, the Russian physicist, Friedman, directly calculated that the universe must be dynamic. But Einstein told him he was wrong. Then, in 1927, Belgian priest Georges Lemaitre showed Einstein his own calculations. He proved the universe was expanding. Einstein looked at the young man coldly and said, "Your math is perfect, but your physics is terrible." After all, to some people, a universe with birthday sounded too close to creation. But the truth was coming quickly. The debate was settled by Edwin Hubble, a former boxer lawyer and self-taught astronomer. In 1923, Hubble pointed telescope at Andromeda. He spotted a Cepheid variable star. It is like a cosmic light bulb with known brightness. Since we know how bright it originally was, so by measuring how dim it appeared, we can deduce its distance from us. It showed that Andromeda was far outside our Milky Way. The galaxy wasn't the whole universe, but just an island in a vast ocean of stars. Overnight, our universe got much bigger. Next, Hubble observed, redshift. Galaxies were actually moving away. The farther they were, the faster they moved. Therefore, the universe wasn't static. It was expanding, like an inflating balloon. It is said that, faced with this proof, Einstein admitted that introducing the cosmological constant was his biggest blunder. Thus, the equations were thrown out, and the idea of a static universe was dead. But a new question arose. If the universe is expanding now, how did it start? Two sides fiercely debated this. The Big Bang camp, led by George Gamow, said the universe began as a dense fireball. They predicted the leftover heat from that explosion should still be everywhere. The steady state camp, led by Fred Hoyle, hated this idea of a beginning. He believed new matter constantly appeared to fill space, keeping the universe eternal. On a BBC show, he mockingly called the other idea as the Big Bang. Ironically, because it was so vivid, this mock became the theory's official name. The debate lasted for 30 years, until 1964. Two engineers appeared, Arno Penzias and Robert Wilson, were testing a sensitive antenna at Bell Labs. They kept hearing a constant hiss in their headphones. It came from every direction. They checked everything. They even climbed inside and cleaned out pounds of pigeon poop. But that damned noise wouldn't go away day and night. And the temperature was exactly 3 Kelvin. Just as they were about to give up, they got a call from Princeton University. Physicist Robert Dicke listened, hung up, then told his team, "We have been scooped." That wasn't a noise. It was the cosmic microwave background. It was the leftover heat from the Big Bang. It was the universe's first cry, still echoing 13.8 billion years later. Hoyle was wrong. The universe had a beginning. The story should have ended here. The logic is simple, that the Big Bang started the expansion, gravity pulls it back. So, the expansion should be slowing down. But, in 1998, two teams raced to measure how much the universe was slowing down. The results shocked almost everyone. The expansion wasn't slowing down. It was speeding up, as if something was pushing galaxies apart, faster and faster. Physics was in shock. Gravity pulls. What pushes? To explain it, scientists had to revive Einstein's discarded constant. It had a new name: dark energy. It's a mysterious force filling empty space, providing repulsive pressure. It grows stronger as space expands. Scientists then calculated the cosmic recipe. Everything we can see makes up just 5% of the universe. Another 27% is the invisible dark matter, and a huge 68% is dark energy, the force tearing the universe apart. If dark energy keeps winning, the fate is the big freeze. Galaxies will fly apart until light can't bridge the gaps. Stars burn out, black holes evaporate, atoms decay. The universe will become an empty void. This sounds hopeless. Science shattered our belief that we're the center of everything, and it even predicts us a cold, empty end. But this even makes our exploration all the more noble. We are just short-lived, carbon-based creatures, yet with math and curiosity, we have traced the story of the cosmos over billions of years. The universe may not care about us. It just follows the law of entropy. And us human, as the sparks that burst forth in the universe, our final dignity is to shine brightly while we can. Then we will leave a sober and immortal epitaph on this vast darkness.